this lovely, adventure in the desert, hanging out, watching this guy and making sure he's walking between these mountains. And yeah, I fell in love with the desert. It was really beautiful.
I love it. Yeah, and like our audience, they're often, they want to know like, how do I become an astrobiologist? And sometimes it's those little things. Just someone comes up to you, hey, do you want to drive a car around the outback for a month? Like, there's little things that can happen that can build not just your community and the people that you know, but also your life experiences.
Oh, definitely, yeah. And I think that's the beautiful thing where I, got into astrobiology and done some amazing stuff, especially out in the Pilbara. Before, I don't know, I love camping and I love, forward driving and these kind of things that I never would have thought would have, helped me get a career in science. So yeah, I think just your passions can take you in really weird and wacky ways.
Very cool. So let's talk about where your passions have taken you then in your research, from undergrad, getting interested in hot springs a little bit in the environment and kind of transitioning more into, environmental geochemistry and kind of working more in this realm. Tell us a bit about your graduate research and what's really been propelling you these last few years.
Yeah, no, definitely. So I've got this amazing group of people that are supporting my PhD research. So I have people at University of California, so Dave Deemer and Bruce Damer, who are really looking at the chemistry of these hot springs, as well as Sudha Rajamani over in Isa and Pune in India, and Kathy Campbell in New Zealand. So there's all these amazing hot spring researchers that are thinking about, could life form in a hot spring? And what our research center kind of realized was that there's all these chemists figuring that out and doing stuff in the lab, and there's all these geologists going out, into the field and studying ancient and modern hot springs, but it wasn't a lot of communication between those two groups. So I'm really lucky. I've got, my rock expert, my rock daddy, Martin van Kranendonk, and then I've got Albert Fahrenbach, who went through the, NASA postdoc program in the States and then came out here to Australia to start up a lab in prebiotic chemistry. And together we're kind of figuring out what works in the lab, why wouldn't that work in the field, or what rocks, what minerals, what real life scenarios could we bring into the lab to kind of ground truth, to try and make these very lofty ideas that chemists make about lipids and RNA and things coming together. If the water was super muddy and if there was gases and splashing and all the kind of fun stuff you get in a hot spring, could that still work? Like, how resistant are our chemical systems? So yeah, that's the work I'm working on at the moment.
Oh, that's so cool. And so you mentioned a few excellent other scientists there. One of them has been on our show. Bruce Damer joined us in a previous episode a few years ago for Ask an Astrobiologist. And, as folks might know from their work and from their work with the Biota Institute, they have a hypothesis that an origin of life on Earth would have been more likely to happen around a terrestrial hot spring environment, as opposed to, as some people have favored, on the ocean floor, around an ocean, a submarine hydrothermal vent. And so we asked our audience on the NASA Astrobio Twitter account what they thought today. And 76% of the respondents thought that life on Earth would be more likely to originate in an ocean hydrothermal vent. I'm curious, Luke, what do you think? Would you think life could originate, or is more likely to originate around a terrestrial hot spring environment, or more likely around a submarine hydrothermal vent?
So firstly, I think that no one really knows yet. We're doing great research in this space, both within, research around these vents, but also in these fields. I personally love these hot spring fields, and maybe I'm biased because I get to go there more and they're a lot easier to walk around in and collect samples from. But to me, the two things I love about these hot springs is, one, their ability to, and this is drawing on like Bruce and Dave's work and other people's research in this space, it's the ability to promote evaporation. So if you want to make polymers, so long chains of DNA or proteins and that kind of stuff, it's quite hard to do without, enzymes and complex cellular machines. People love an origin of life happening on the Earth's surface, but also it's to do with complexity. So if you go to a hot spring site, there are literally tens of thousands of hot springs, and they're all got different temperatures, different pHs, different, elements and minerals dissolved in them. And when you think about how complex life is and how many different reactions are needed for life to form, I think that having a place of 10,000 different chemical environments will be a lot easier to get that, one little chance of it just linking up the right way. We're in an event which are, beautifully chemically rich systems. The more, even though if within a field, it's a single point source. It's like one vent going out into a dilute ocean, and you only get one real main chemical gradient in that space. So that's some of the arguments people make, but also vents are really cool. So yeah,
Around an island chain and how, in an island or an archipelago of hot springs, you might have a lot of different experiments occurring as well. That's really cool to think about. Now, I do want to talk a little bit before I open up to our audience. And by the way, for those watching on YouTube right now, you can ask questions in the chat. Those will start coming over to me to ask Luke as well. And also for those watching later on, you can always reach out to Luke later on as well. I do want to talk a bit about your work now in science communication too. Not only have you been working in this realm of hot springs, both with ancient and modern, you've also been doing a lot of work in communicating science. And as you mentioned, like seeing these people in a bar or wherever, where they're just interested in what we're learning about astrobiology and what we can share. I'd love to hear from your perspective why you think we scientists should maybe communicate our science, or why we should be involved in the process of communicating our science.
Yeah, no, definitely. So I think on one hand, and I don't know how it worked in the States, I imagine it's similar, but in Australia, all the funding you're not curing cancer, you're not building a faster car. Like what's the value of this to society, which, is a valid point. Resources are, finite, but I see so much beauty in astrobiology. I see so much of that ability to connect humans together, but also to understand complex, biology and medicine, to develop new technology to go to other planets. Is such an amazing value of astrobiology. It's just the way we communicate that. But then again, at the same time, I think that we have